Great, let's take a look at Chapter 14, Section 2, Measures of Tendency. In this chapter, we'll want to compute the mean, median, and the mode of distributions, find the 5-number summary of a distribution, and apply measures of central tendency to compare data. The mean and the median. Computing the mean. If a data set contains n data values, the mean x-bar of the data set is x-bar equals the sum of x divided by n. We use the Greek letter sigma, capital sigma, to indicate a sum. For example, we will write the sum of the data values 7, 2, 9, 4, and 10 by sigma x equals 7 plus 2 plus 9 plus 4 plus 10. We represent the mean of a sample of a population by x bar, and we will use the Greek letter mu to represent the mean of the whole population. So the mean of a sample is x bar, the mean of a population is mu. Example, a car company has been studying its safety record at a factory and found that the number of accidents over the past 5 years was 25, 23, 27, 22, and 26. Find the mean annual number of accidents for this 5-year period. Solution. We add the number of accidents and divide by 5, the number of years. X bar equals sigma x divided by n. We add the data values and divide by the number of data values. So we sum 25, 23, 27, 22, and 26 to get 123. As we divide by 5, we get 24.6. Another example. The water temperature at a point downstream from a plant for the last 30 days is summarized in the table. What is the mean temperature for this distribution? Here we're given temperatures and frequencies. So we had a temperature of 52 degrees Fahrenheit 4 different days, and a temperature of 53 degrees Fahrenheit on 6 different days, a temperature of 54 degrees Fahrenheit on 3 different days, a temperature of 55 degrees Fahrenheit on 8 different days, 56 degrees Fahrenheit on 4 different days, 57 degrees Fahrenheit on 5 different days. If you sum the total frequencies, you'll get 30, which is good because there were 30 days. A third column is added to the table that contains the products of the raw scores and their frequencies. So this time, we're not finding the relative frequency dividing f by n. This time we're multiplying x times f. So we take the product across the row. We say that since it was 52 degrees on 4 different days, we could add 52 plus 52 plus 52 plus 52, and then 56, 53 plus 53 plus 53 plus 53 plus 53 plus 53. Or we could just multiply the 4 times 52 and get a sum of 208. So if we multiply straight across the row, x times f is 208, x times f is 318, x times f is 162, x times f is 440, x times f is 224, x times f is 285. Then we sum this column. When we sum this column of the products, x times f, we get 1,637. So the sum of the scores here is the sum of all the x times f's divided by the total number of frequencies, the total number of days. So over the sum of each day's temperature summed to 1,637 degrees. We divided that by the 30 days that we recorded. We found that there's about a 54.6 degree Fahrenheit average for this month. Computing the mean of a frequency distribution. We use a frequency table to compute the mean of the following data sets as follows. 1. Write all the products XF, X times F, of the scores times their frequencies in a new column of the table. Step 2. Represent the sum of the products you calculated in step 1 by the sum of the XF. So sum that column. Denote the sum of the frequencies by sigma F. Sum the number of frequencies. Then step 4, the mean is then sigma XF divided by sigma F. So the sum of the XF column divided by the sum of the frequency column. Example, listed are the yearly earnings of some celebrities. What is the mean of the earnings of the celebrities on the list? So we have 10 celebrities from Oprah Winfrey to Angelina Jolie. And in 2007, we have their earnings in millions of dollars, where Angelina Jolie is at a low $20 million for the year. And Oprah Winfrey is at $260 million. So question A, what is the mean of the earnings of the celebrities on this list? B, what is the mean? Is the mean an accurate measure of the average earnings for these celebrities? Summing the salaries and dividing by 10 gives us a sum of 648 divided by 10, which is an average of $64.8 million. So sigma X divided by N is to sum the X column and divide by the number of celebrities. 648 divided by 10, in terms of the question, yields $64.8 million. 8 of the celebrities, and the solution to part B is that 8 of the celebrities have earnings below the mean, whereas only 2 have earnings above the mean. The mean in this example does not give an accurate sense of what is average in this set of data because it was unduly influenced by higher earnings. So Steven Spielberg and Oprah Winfrey are the only people who made more than $64.8 million. So 8 are below, 2 are above. The mean isn't an average of it. A mean isn't a good measure of the center there. What would give us more of a center, 5 above and 5 below, would be this concept of the median. Computing the median. If we arrange a set of numbers in increasing or decreasing order, the median is the middle value in the list of numbers. However, there are 2 cases to consider. If an odd number of numbers or an even number of numbers. So if n is odd and there is an odd number of numbers, then the median is the number in the middle position. If there is an even number of numbers, n even, then the median is the average of the 2 middles. For example, if we had a list 1, 2, 3, 4, 5, there's an exact middle when you have an odd amount. If you have the numbers 2, 4, 6, 8, 10, and 12, there's no exact middle. So we average the two middles to find the middle to be 7. So when you have an exact middle, that's the case of having odd number of numbers. If you don't have an exact middle, you have an even number of numbers, and then you have to average the two middlemost numbers. Example, the table lists the ages at inauguration of the presidents who assumed office between 1901 and 1993. Find the median age for this distribution. So Roosevelt was 42, Clinton was 46, and everyone in between, which I think the oldest were in their 60s. Solution. We will first arrange the ages in order to get 42, 43, 46, 51, 51, 51, 52, 54, 55, 55, 56, 56, 60, 61, 61, 64, 69. There are 17 ages, an odd number. The middle age is the 9th. So half of 17 evenly would be half of 16, which is 8. And so the 9th entry, which is 55, is our exact middle. If we tried to cut the list as it's written pre-sorted, 1, 2, 3, 4, 5, 6, 7, 8, 9, we would have picked Eisenhower at age 61, and we would have been incorrect. So the median is the middle of the sorted list. Example, 50 32-ounce quarts of a particular brand of milk were purchased and the actual volume determined. The result of this survey are reported in the table. What is the median for this distribution? 27 ounces. Eight of these 32-ounce quarts were listed at 27 ounces, 5 at 28 ounces, 12 at 29 ounces, 16 at 30 ounces, and 9 at 31 ounces. None of them were 32 ounces. Okay, nonetheless, the sum of the frequencies is 50, which is good because we were told that we were examining 50 32-ounce quarts. Because the 50 scores are increasing order, the middle two scores are in position 25 and 26. We see that the 29 ounces is in position 25 and the 30 ounces is in position 26. The median for this distribution is 29 plus 30 divided by 2, which is 29.5. So if we take a look at our table, right, we're not just saying 1, 2, 3, 4, 5 X values, and so the middle is 29, right? That's not the concept here. What we have is we have 8 27s, and then some 28s, and then some 29s, right? 2, 4, 6. And when we write out the list completely sorted, after 25 scores, we'll hit the 29, because here we have 8 plus 12 is 20, 25. Half of our list cuts off at the 25, and the other 25 is down in the bottom. So by the time we hit the 25th entry, we'll have the 29. And on the 30th, 26th entry, sorry, I was looking at the wrong column, we will have the entry 30. So we'll sum 29 plus 30 and average it to get 29.5 as our median. All right, now we're going to look at the 5-number summary. The 5-number summary involves 5 numbers, one of which is the median. So the median divides a data set into 2 halves. The set of numbers below the median is called the lower half, and the set of numbers above the median is called the upper half. And they mean in terms of values. So if your numbers are less than your median value, that's your lower half. And if your numbers are greater than your median value, those numbers are in the upper half. The median of the lower half is called the first quartile and is indicated by Q1. The third quartile, denoted by Q3, is the median of the upper half. The 5-number summary is a set of data values consisting of the following 5 numbers. We want the minimum value, the Q1, the median, Q3, and the maximum value. Example, consider the list of ages in the presidents from the previous example. Find the following for this data set. So here we have 2, 4, 6, 8, 10, 12, 14, 16, 17. Okay, so check, 17 presidents from before. Find the following for the data set. The lower and upper halves, the first and third quartiles, and the 5-number summary. Solution. Finding the median, we can identify the lower and upper halves. So again, we have to sort our list. Once we've sorted it and identified the 55, that particular 55 joins neither the lower half nor the upper half. And this is when you have an actual middle entry. So this is when we have n is odd, an odd number of numbers. When you have an odd number of numbers, the median is a real entry and it joins neither half. So the lower half is 42, 43, 46, 51, 51, 51, 52, 54. Then we skip our median, and our upper half is the other 55, the 56, 56, 60, 61, 61, 64, 69. Now the median of the lower half is to split that list in half, but now there's only an even amount. There's 8 on each side of the median. 8 plus 8 plus 1 is 17. Half of 8 is 4. So the halfway point of the lower half is between the 51 and the 51. And the halfway point between the upper half between the 60 and the 61. So Q1 is the halfway point in the lower half, and Q3 is the halfway point in the upper half. So Q3 is 60.5, averaging the 60 plus the 61 divided by 2. And the Q1, the halfway point of the lower half, is 51 plus 51 divided by 2, which is also 51. The 5-number summary then is to pluck off the low number, pluck off the high number. So a 42 for our low, a 69 for our high, a median at 55, a Q1 of 51, and a Q3 of 60.5. Those 5 numbers form our 5-number summary. What we do with this information, 42, 51, 55, 60.5, and 69, is we represent it in what's called a box and whisker plot. So we represent the 5-number summary by this graph. First of which, you'll draw yourself a ruler on the bottom. This is a graph, so consider needing a horizontal axis where you label the quantities that we're looking at. These are ages of the presidents. They range from 40 to 70. You want to go a little below your low and a little above your high. So the minimum was 42, we'll start at 40. The maximum was 69, we'll start at 7, we'll end at 70. And then once you have a nicely structured ruler with equidistant tick marks and meaningful tick marks, then what you do is you insert little dash lines for the 42, the 51, the 55, the 60.5, and the 69. And now the whisker extends from the minimum to the maximum. The whisker shows the min and max, and the box shows the middle 50%. So you form a box around your Q1 median and Q3 range of info. But the whisker goes all the way from the minimum to the maximum. So in the box and whisker plot, the whisker represents the min and max, and the box represents the middle 50%. Now, let's look at another measure of central tendencies, which is the mode, right? So we're looking at the mode of a set of data is the data item that occurs most frequently. If two items occur most frequently, then each is a mode. If more than two scores occur most frequently, then we say that there is no mode. Example, find the mode for each data set. In group A, we have double fives, right? So the mode is 5. There's no other doubles. In B, we've got double 4s, but we have triple 3s and we have triple 9s. So our mode is both the 3 and the 9. In example C, we have 98, 99. Nothing is duplicated. So here in C, we have no mode because every frequency is frequency 1. And in D, we have doubles of everything, well, except for the 5. But we have double 2s, double 3s, double 4s. That's too many modes. So again, we have no mode, but for a different reason, right? We have no mode in D because there's too many, and we have no mode in C because nothing is most frequent. Everything has a frequency of 1. Comparing measures of central tendency. Assume that you are negotiating the contract for your union. You have gathered annual wage data and found that 3 workers earn $30,000, 5 workers earn $32,000, 3 workers earn $44,000, and 1 worker earns $50,000. In your negotiations, which measure of central tendencies should you emphasize? So we have our salaries here. We have 30, 32, 44, and 50. Frequency of 30 is 3, frequency of 32 is 5, a 44 is 3, and a 50 is 1. So do we use the mean? Do we use the median? Or do we use the mode, right? Potentially, we use the mode, but maybe we'll use one of the others, right? Let's see what the book says. Solution. Our mode is calculated at 32,000. Well, we saw that one. The median is also 32,000. So those are both good measures. The mean, however, which was x bar equals sigma xf divided by sigma x, so the sum of the x values times their frequency divided by the number of frequencies, yielded 432 divided by 12, which is 36. The mean is 36,000. To make the salaries appear as low as possible, you would want to use the mode and median.